Moving into section 8.1, completing the square. Before we actually get into completing the square, I want to talk about this property known as the square root property. So here's how I'm going to get you to see this property. I'd like us to solve this problem. So we learned how to solve this by factoring, did we not? Okay, so this factor is very simply, if you recall, 2x minus 3 times the quantity of x plus 3. And then what do we do with each parenthesis? That's right, we set them equal to 0. And after we set each one equal to 0, we have something very nice and simple to solve. And we end up with x equaling 3 and x equaling negative 3. Do you agree? Good. Now here's the deal. I have another way of solving this problem. If I take this problem, x squared minus 9 equaling 0, and I'm trying to get x by itself, then I would have to move that 9 over, wouldn't I? So when I move that 9 over, I have x squared by itself, but I don't have the x by itself, do I? Okay, so that means I need to get rid of that square root. Agreed? So what's the opposite of a square root? What cancels a square? Pardon me. What's the opposite of a square? What cancels a square? Yeah, a square root cancels a square, which means I would take the square root of both sides, wouldn't I? So most of us would say the answer would be equal to 3. But here's the thing. We need to remember that we're actually supposed to get 2 answers. Just like this problem. This is the exact same problem, except I'm solving it a different way. So what we need to remember is that when I take the square root of 9, and I'm supposed to get 2 answers, x isn't equal to just a positive 3. X is also equal to a negative 3. And this first way that we first learned how to solve these things by factoring shows us I'm supposed to get 2 answers. I'm supposed to get a positive 3 and a negative 3. Well, when I solve it by a different method, I'm still supposed to get the exact same 2 answers. Nothing changes on that. Are you with me? Okay, cool. Hang in there. I got some more problems for us coming up. Okay, so let's look at these problems. The first one I'd like to look at is number 2 here. So I'm trying to solve for x. I'm trying to get x by itself. Agreed? All right, so if you're trying to get x by itself, then the 21 needs to move over, doesn't it? And you move it over by, good, adding, which means I would have x squared equal to 21. Agreed? And then, to get the x by itself, you need to get rid of that square, and the opposite of a square is a, excellent, square root, which means I take the square root of both sides, don't I? Now please remember, this square means you're supposed to get how many answers? Good, 2 answers. So I know that what remains on the left side is x, and they didn't say anything about giving them a decimal answer, so I can't go to my calculator. So I need to figure out the square root of 21. Well, it's not a perfect square, so x would be equal to the square root of 21. But remember, just like the last problem we did, it's not equal to just a positive square root of 21. It's also equal to the negative square root of 21. You get 2 answers, a positive answer and a negative answer. Cool? Okay, let's look at problem number 3. Again, I'm trying to solve for x. I'm trying to get x by itself. So what's the first thing I need to do? Good, subtract the 64. So I end up with x squared equaling a negative 64. And then I need to get rid of that square, don't I? So what will cancel a square? Good, a square root on both sides. And I'm supposed to get how many answers? Excellent, 2 answers. So here's the deal. One answer will be x equaling, you're like, I can't take the square root of a negative 64. Yes, you can. We've already done that, haven't we? Remember, write it as the square root of -1 times the square root of 64. Ah, yes, the brain has re-engaged on that concept. And the square root of 64 is, excellent, 8. And the square root of -1 is, yep, there's that I, there's that notation, right? But remember, two answers. Your answer isn't just a positive 8i. Your answer is also a, good, negative 8i. Two answers. Good? Okay, let's look at this third problem. Again, I am trying to get z by itself, so what's the first thing we need to get rid of? Excellent, that 38. So I'll have 2z squared equaling a positive 38. I'm still trying to get z squared by itself, so then, correct, divide by the 2, which gives you 19. And then finally, you've got to get rid of that square, don't you? Which means you've got to take the, good, square root of both sides. Now remember, you're supposed to get how many answers? 2. So, 19, not a perfect square, which means I end up with z equaling the positive square root of 19 and z equaling the, good, negative square root of 19. Does this make sense? All right. So, number 4. I'm trying to get x by itself, aren't I? Okay, now you know you have to get rid of the 1. But you notice there's that square kind of holding this x and this 1 together because of the parentheses. So I can't pull the 1 away yet until I get rid of that square. Agreed? So, interestingly enough, right off the bat here, you're going to have to take the square root of both sides. You're going to have to like raise the roof, so to speak. So, what remains on the left side would just be x plus 1, correct? And you know the square root of 9, it is, good, 3. But remember, you're supposed to come up with 2 answers. The square root of 9 isn't just a positive 3. The square root of 9 is also a, excellent, negative 3, which means you don't only have x plus 1 equaling a positive 3, you also have x plus 1 equaling a negative 3. This actually breaks out into 2 equations. And they're 2 simple equations for us to solve. In this case, after you minus the 1, you'll get 2. And over here, after you minus the 1, you'll get a negative 4. Good? Be careful on number 4. In this case, the square has to go first because it's so to speak on the outside of everything and it's holding everything together. And if I can get rid of that square, then I get rid of that parenthesis and then I can tackle the 1. Good? Okay, hang in there. Got a couple more problems for you. Okay, so let's take a look at 2 more problems. Let's take a look at number 6. I'm trying to solve for x. The 12 is in my way, but do you notice the square is also in the way? So what do I get rid of first? Excellent. I've got to get rid of the square because the square is holding this parenthesis together and intact. So I need to take the square root of both sides, don't I? Which on the left will leave me with just x minus 12, won't it? But remember, you're supposed to get how many answers? Excellent, 2 answers. One answer is, good, positive. The other answer will be, good, negative. So let's take a look. 45. Is 45 a perfect square? Nope. So let's break down that 45. That's 5 times 9, right? And then a couple of 3's, which means if I take the square root, since I have a pair of 3's, I'm going to take the square root of 3 squared times 5, which would be 3 square root of 5, wouldn't it? Okay, so just as a reminder on how to do this, so hang in there one quick second. I'm going to give myself just a little more room to work. So I have x minus 12 equaling to a positive 3 square root of 5. I also have x minus 12 equaling a negative 3 square root of 5. And then I have to move this 12 over, don't I? So I get to add 12 to both sides. Agreed? All right, so when you add the 12 to both sides, can I add the 12 and the 3 square root of 5? Correct, you cannot, because they're not like terms, are they? So you would have x equaling 3 square root of 5 plus 12, wouldn't you? Now, the order that we like to write this is we actually like to write anything with the square root last. So, the 12 is positive. I know the square root of 3 plus 5, square root of 3 times 5, or 3 square root of 5 is positive. Sorry about that. So, as funny as the answer looks, that's one of the answers for this problem. If I look over here on the second half of this problem, again, I add 12 to both sides. Can I add the 12 and the negative 3? Excellent, you cannot, because one has a square root and one does not. Which means, again, write the number without the square root first and the square root last. So, two very interesting answers to this problem, but these are the answers to this problem. A 12 plus 3 square root of 5 and a 12 minus 3 square root of 5. Good? Okay, let's look at problem number 7. Again, the square has got to go, so we have to square root both sides, don't we? All right, which means I am going to get 4x minus 3 equaling, square root of negative 49. Yeah, that's 7i, isn't it? But you have how many answers? Good, 2 answers. So I have 4x minus 3 equals a positive 7i. And your other one is 4x minus 3 equaling a, excellent, negative 7i. And in this case, we add 3 to both sides, don't we? May I add 3 and a 7i? Nope, can't do it because they're not the same, are they? So I have 4x equaling 3 plus 7i, and then you get to divide by 4, don't you? Sorry, I'm going to erase this to give myself a little bit more room to work. So we end up with x equaling 3 plus 7i, the whole thing divided by 4. But you have to write them as 2 separate fractions. You can't leave them as one fraction, can you? Okay, so that's one of my answers, 3/4 plus 7 over 4i. Let's go find that other answer. Okay. We knew when we took the square root of a negative 49, we didn't just get a positive 7i, we also got a, good, negative 7i. So I have 4x minus 3 equaling a negative 7i. I need to add the 3 to both sides. Can you add an I with a non-I? Good, you cannot, which means I end up with 4x equaling 3 minus 7i. And then you've got to divide by 4, don't you? Just like you did on the first answer. Agreed? Okay, but remember, you have to write them as 2 separate fractions. The real part first, the imaginary part second. You with me? Does this make sense? Okay, cool. Hang in there. We're heading into completing the square. Okay, so I'm back. We're going to look at completing the square now. Before we actually do any of that process, I would like you to take a look at this polynomial that I put up here on the board. And if I asked you to factor it, you could factor this one. This one's actually quite easy to factor, isn't it? So notice, it would factor to x plus 5 times itself, wouldn't it? You'd get 2 of them, wouldn't you? So, I got a question for you. Why did you choose 5 when you factored it? Why did you say, obviously I know the x, but why did you choose 5? You chose 5 because 5 times 5 is 25, isn't it? But isn't 5 plus 5 also 10? Okay, got another one for you to look at. What happens if I asked you to factor x squared minus 8x plus 16? What would you get if you factored that? Okay, so I'm hearing you say x minus 4 times itself, right? And I agree. Why did you choose 4 again? Because you're saying 4 times 4 is 16, and 4 plus 4 gives you the 8. Agreed? Okay, here's an observation I'd like you to recognize. This x squared plus 10x plus 25 is a perfect trinomial. Because when you factor it, you get something times itself, don't you? The same with x squared minus 8x plus 16. It's a perfect trinomial because when you factor it, you get something times itself, don't you? Okay, here's what I'd like you to notice. This 5 isn't, if I take the 10, the middle number, if I cut it in half, don't I get 5? You do, don't you? And if you square it, don't you get 25? Look at the negative 4, okay? How really, right, is that negative 4? How do I really get that? Well, if I take this negative 8 and I cut it in half, don't I get that negative 4? And if I square it, don't I get this positive 16? So interestingly enough, it's a pattern. The number you're choosing here happens to be half of this middle number. And then when you square it, you end up with this last number at the end. Are you with me? Okay, so now, remember this. I'd like you to complete the square. I need to know what this last number is going to be if it's going to be a perfect trinomial. So it factors to something times itself. Now look at these two over here. Remember what happened. This number you found was half of this middle number, wasn't it? And then when you squared it, you got this 25, don't you? So if I take my middle number, which in this case is, positive 20, and I take half of it, what would you get? Good, you'd get a positive 10. And then if you square it, you would get, that's right, you would get 100. Now, answer me this. If you factored this polynomial, r squared plus 20r plus 100, what would it factor to? R plus, 10. Because 10 times 10 is 100 and 10 plus 10 is 20, isn't it? Right? Okay, hang in there. Let me get myself a little bit of board space. And let me put another one up for you. Let's see if you can get this one. Okay, I need to fill in that blank. What do you think? I need it to be a perfect trinomial. So when I factor it, I get something times itself. Okay, so remember the pattern. The pattern is that if I look at that middle number and I do what to it? Yeah, take half of it. What do we get? Good, negative 6. And then if I square it, I get, excellent, 36. Okay, if you factor it, if you factor this trinomial, you would get z squared, excellent, minus 6. Oops, excuse me. I put the square in too soon. My apologies. You would get z minus 6 squared, because negative 6 times itself is 36, isn't it? And negative 6 plus negative 6 is negative 12, isn't it? Just like on this problem, positive 10 times itself gives you the positive 100, and positive 10 plus positive 10 gives you positive 20. Agreed? Okay, I got one more that I want to put up on the board here. So let me get some board space. So bear with me a second. Okay? What do you think so far? Not too bad? Keep it that way. These type of problems are not really bad. And I promise we didn't pull it out of the thin blue air. We noticed a pattern with the perfect trinomials. When they factor to themselves, the number that we put in this parenthesis was always half of the middle number. And then when you squared it, you got the last number. So here's one more. Little bit of a brain teaser, but you can handle it. Okay. I need to fill in that empty spot there. So remember, the pattern doesn't change. Just because the 3 does not divide nicely by 2 doesn't mean that my pattern changes. It remains the same. I'm going to take this middle number and I'm going to divide by 2. And no, I'm not going to make it a decimal. I'm going to leave it as a fraction. And then you're going to square it, aren't you? Which will give you, 9 over 4. Agreed? Now some of you are like, I really don't like that last number that we added in there. And I understand that. But you know what? It factors just as nicely as this problem did. Watch. And I'm going to write it out twice. We have an x and an x, and they're both going to be positive, right? Okay. So let me go back and look at this one over here. If I wrote this out, 2 parentheses first, you would have said a z and a z. You would have said a minus on both of them, wouldn't you have? And then, what would you have put for number 2? You would have put 6's, wouldn't you? Because, look at the double smile in the middle. That's a negative 6z, and that's another negative 6z, which gives me the negative 12z in the middle, doesn't it? And it gives me the positive 36 at the end, doesn't it? Okay, so here, I need the square root of that. Just like here, when you put in the 6's, you took the square root. You took 6. So, if I put 3 over 2, because that's what I got here when I took half of the 3, right? You put minus 6 because that's what you got when you took half of the negative 12, right? If I put 3 halves, that should be my result on factoring, shouldn't it? Now, some of you are not buying that you would get a positive 3 if you redistribute. Let me show you. Again, look at the double smile. A positive 3 over 2x and another positive 3 over 2x. Okay, so help me out. What's 3 over 2 plus 3 over 2? Yep, 6 over 2. What's 6 over 2? 3. It works. It doesn't matter if the middle number is not a even number. If it's an odd number, fine. So I end up with a fraction. But because I'm making it perfect, this is going to end up to be very easy to factor still. Good? Okay, so hang in there. We're going to solve some problems using this completing the square technique. Okay, so I'm back. So we're going to solve some problems by completing the square. Now, I'm going to let you know this technique isn't the best technique for solving, but we're going to do a couple of problems just so you can see how we do this. Now, if I'm going to complete the square, remember the last 3 problems that we did? We had to fill in a missing third term, didn't we? So the 3 problems that we just did not have a third term, did they? So the first thing I'm going to have to do is get rid of this 9. So I'm going to move that 9 to the other side. Why? Because I don't want a third term there. I am supposed to put in this missing third term. Okay, that's what we did on the previous 3 problems. We're putting in the missing third term. So if it has a third term, you've got to get rid of it. Good? Okay, so now this left side looks like those last 3 problems we did. Agreed? So, to complete the square, we are going to take the middle number and we are going to take half of it, which gives us, good, 4, and then we get to square it, which gives us, excellent, 16. So that means I'm going to add 16. This is the third number that I'm really looking for. This is the third number that makes this polynomial perfect. With me? But if I add it to one side, yep, I hear you, you have to add it to the other side, don't you? Okay, which means my line now looks like x squared plus 8x plus 16 equals 7. Agreed? Now, remember the last 3 problems we did. After we completed the square, we could factor it to something times itself, couldn't we? So, what happens when you factor this x squared plus 8x plus 16? Yeah, it factors to x plus 4 times itself, doesn't it? Right? And now this problem looks like one of the problems that we did in the very beginning of this particular lecture. When we are solving for x, we need to get rid of the 4 and the square. Agreed? Okay, so what's got to go first, the 4 or the square? Yeah, the square. So that means you got to square root both sides, don't you? And how many answers are you going to get? Yep, you get 2 answers. So this means that x plus 4 equals a positive square root of 7 and x plus 4 equals a negative square root of 7. Yes? Okay. So up here, how do you get the x by itself? Good, you minus the 4 from both sides. So can you combine a square root and a non-square root? Excellent, you cannot, which means in this case x will equal a negative 4 plus a square root of 7. So there is one answer. Down here, again, minus the 4. Same question. Can you combine a square root with a non-square root? Excellent, you cannot, which means I end up with x equaling a negative 4 minus square root of 7. And here will be answer number 2. Cool? Yeah, this one we could have actually done it maybe a little bit differently, but to solve it, but I want you to see how completing the square actually leads into this square root property. Okay, hang in there. I got another problem. Okay, so I'm back with another problem. So let's take a look at this. I want to solve this by using our completing the square technique. And remember, just like we discussed in the last problem, we do not have a third term. So this third term needs to go away. We're actually going to be looking for the third term. Now, In those problems where we completed the square, not only was there not a third term, there was not a number in front of your x squared, your r squared, your p squared. And in this case, I have a 4 in front of it. That 4 is not supposed to be there. There wasn't a third number, and there wasn't a number in front of my squared variable. So in this case, I need to get rid of that 4. Now, help me out. What's the operation between the 4 and the p squared? Good, multiplication. So how do I break multiplication? Excellent, divide, which means everything, both sides need to get divided by that 4. Are you with me? Which would leave me p to the second minus, good, 3p equaling this lovely fraction of 3/4. So now the left side looks like it's supposed to. No third number and no number in front of the p squared. Now I'm ready to complete the square. And remember how you complete the square. You take half of this middle number and then you square it, which will give me a 9/4. Gee, that looks like one of the other problems that we worked on, didn't it? That's good. Just verifies what we have done before, so we get it. And so that means this third number is 9/4, isn't it? But if I add it to the left side, good, you have to add it to the right side also. You with me? Okay, so I'm going to bring this problem up here. So I have p squared minus 3p plus 9/4 equaling, yeah, gratefully these fractions have the same denominator, and so I get 6/4, don't I? Okay, so remember, we completed the square here, which means this is going to be a very simple polynomial to factor, because this is a perfect square. So remember what we did before. We're going to get p minus, good, 3/2 squared, quantity squared. And 6/4 reduces, doesn't it? Yeah, 2 goes into here 3 times, 2 goes into here twice. That's a coincidence. Don't think anything of it. It's a coincidence. Cool? Okay. So now it becomes like we've done before. We need to square root both sides, don't we? Which means we're going to get how many answers? Good, 2 answers. So one answer is going to look like p minus 3/2 equals, that's right. You know, I'm changing my mind a second. I know I could reduce the 6/4 to 3/2, but I'm changing my mind a second because on here, I'm going to get a square root left in the denominator. And am I allowed to leave a square root in the denominator? Good, you're not, which means you'd have to rationalize, right? Okay, I don't want to rationalize. But what I'm noticing is if I left it as 6/4, the 4 is a perfect square, isn't it? The 6 may not be, but the 4 is, and that's fine with me because I may not be able to take the square root of 6, but I can certainly take the square root of 4, which is, good, 2. So, but you're going to come up with 2 answers, aren't you? I'm going to create myself some space over here. So your second answer would look like p minus 3/2 equaling a, good, negative square root of 6/4. We were very fortunate that that 4 was there in the denominator because it saved us from having to rationalize. All right, how we doing? Making sense? Okay, so now I need to get rid of this 3/2. So add it to both sides, right? And can you add a square root with a non-square root? Nope, you can't. So you end up with p equaling positive 3/2 plus square root of 6 over 2. Are you with me? And by the way, since these two denominators are the same, and this is not an imaginary number, there's no I here, sometimes the authors of the book will combine them into one fraction since the denominators are the same. So this would be one of your answers. Now, over here, I would add the 3/2 to both sides. And again, can you add a square root with a non-square root? Whoops, nope, you can't. Sorry, I got carried away with that 4. It should have been a 2, shouldn't it have been? See, this is why it's good you do the work with me. So I have p equals positive 3 over 2 minus square root of 6 over 2, which they would write as one fraction also. So 3 minus square root of 6 all over 2. So here would be your second answer. 3 plus square root of 6 over 2 and 3 minus square root of 6 over 2. Good? You with me? Okay, you have fun with these, and I'll catch you on the flip side.